There's no room. I don't need to be up here. No, that's all right.
I'm happy to stand. I'm actually perfect. I can just go.
All right, well, thank you. Look at this great panel we have here.
Never had so many utility people set this close.
Yeah, I know.
Yeah, we're a little uncomfortable.
Yeah, let's see what happens.
Got the arm length over here. I think I'm ready too.
Well, thank you all. So, my name is Peter Christensen. I am an industry engagement advisor at P&L, and I'll be moderating this panel discussion on the industry perspective for the Advanced Grid Institute and their research and development priorities. From the very beginning, when the AGI was formed, industry input was and is considered a critical aspect of the success of AGI. Therefore, an industry engagement or an industry advisor board was formed with the stated purpose, and I quote from the charter, to provide guidance to the AGI co-directors and to assist with engaging the electric utility industry and power engineering community to further the mission and vision of the AGI. So I am honored to introduce to you our members of our industry advisory board who agreed to come here today and share their thoughts about how their industry works with AGI and their research and development priorities. So we have here today, and I'm going to do this in alphabetical order, so don't read anything in the order. We have Larry Beckendorf, Senior Vice President of Advanced Energy Delivery at Portland General Electric. Eleanor Uri, Manager of Transmission Strategy and Markets at Puget Sound Energy. John Gibson, who you've already met, Chief Research and Development Officer or Development Engineer at Vista. Nicole Rutherford, who just joined our panel, Chief Technology Innovation and Strategy Officer at Bonneville Power Administration. Thank you, Nicole. Uzma Siddiqui, Senior Manager of Grid Modernization and Strategic Technology at Seattle City Light. And Rich Wallen, thank you for coming, General Manager and Chief Executive Officer of the Grant County PUD. And there is one more member of our...
We have Deb online.
Is he online?
Yeah.
Oh, Greg. Greg, I'm glad you Greg Zweig, Chief Technology Officer at Schweitzer Engineering Laboratories. So it's not all utilities. We do have some other manufacturing support. So again, welcome, and again, thank you for being here today. What I'd like to ask each of the panelists is to just give a brief 3 to 4 minute introduction about what they do and a brief summary of their perspective of how AGI has and can benefit their industry and what their R&D priorities are. And then we'll have plenty of time to open up the panel to questions from the audience and make this more of a discussion session rather than presentations, and no slides for the session. So, and given how, Greg, you're online, I know that someone whose name starts with Z always goes last, so we're going to do this backwards today. Greg, do you want to start? Give your introduction. Are you there?
Yeah, I'm here. Can you hear me okay?
Yeah, hear you loud and clear. Thank you.
Okay, great. Well, I can't see, my screen isn't showing any of the room, so I'm not able to see anyone, but I'll speak, and that'll work okay. So, yeah, at Schweitzer Engineering Laboratories, we're a manufacturer here in the Pacific Northwest out of Pullman. Probably many of you know about SEL. We manufacture protective relays, communication equipment, automation equipment, comms equipment, I mean, just a host of things, software. And, we've been participating with AGI and this initiative for a while, and it's been really good, and I appreciate the opportunity to be part of it. I guess I could share a few things about AGI. I think one of the things that's interesting for us is some of the research that is being done in the networked microgrid coordination, the grid forming and grid following inverters, your distribution management platform, I think you call it grid apps. And, there's a lot of other things. And this really relates to what we do. We make a PowerMax microgrid solution that, it does generation control, load sharing, load shedding, auto synchronization. There's a lot of things that it does. And so, it's interesting for us what's happening at the research level when it comes to microgrids. And then in terms of, distribution management, we're doing a lot of things with distribution automation on more virtualized platforms, which is, I think, a really interesting area, distributed architectures and things of that matter. So that I'm going to make sure I answer your questions. That's some of our work with Advanced Grid Institute. Would you like me to talk about our research initiatives now, or would you want to go around the panel to talk about work with AGI and then kind of come back to each panelist on some of their research priorities?
Yeah, thank you, Rich. Yeah, let's just do our introductions and we can go into more detail on the next round. But thank you, Greg. I appreciate that.
Okay.
Again, and great introduction. Rich Wallen, you want to go next?
Rich Wallen, General Manager, CEO at Grant PUD. We are situated, for those that are not aware, in Central Washington, Moses Lake area. We have about 2,100 installed megawatts of capacity on the Columbia River with 2 hydroelectric facilities. Customer base of around 53,000 meters, approaching 5,000 miles of distribution and about 500 miles of transmission, and ever growing. Our large customer queue right now, our peak load was set back over Martin Luther King Day weekend, around 1,080 megawatts. We have over 3,200 megawatts currently in our queue. So we are leveraging AGI and the partnerships, and we think that those continued partnerships between consumer-owned utilities like ourselves, as well as investor-owned utilities, along with the public and politically, are what we're going to need to meet the future demand, because we simply just have a math problem, and we're looking for every opportunity that we can, whether it be grid enhancement technologies, superconductors, as we explore anything and everything, because we truly believe it's going to be an all-of-the-above solution if we're going to meet the clean energy goals and targets that we all have in front of us. We currently are exploring everything from small modular reactors to hydrogen technology to help meet that need in the short term. But we all know that it hinges on transmission and distribution at the end of the day, and that's where we really see the value in AGI.
Excellent. Thank you very much. Continuing on backwards order, Uzma.
Hi, my name is Uzma Siddiqui. I work for Seattle City Light. Greg works for SEL. I work for SCL. So every now and then I like listen to him twice and I'm like, okay, yeah. So Seattle City Light, for those of you who are not familiar, we are a municipal utility and we serve the city of Seattle, but also 8 other governmental organizations, customers in other governmental organizations. So for example, in Tukwila and in Shoreline and in unincorporated King County. So one of the interesting things for us is always that we have sometimes the city of Seattle rules and then the state of Washington rules that both apply. And it makes for a little complication. Our all-time system peak was in 1990, but we came really close on Martin Luther King weekend this last year. And our resource guy was saying, well, what if the weather had been just like 1990? And he said, well, then our load would have been higher and significantly higher. So I guess it was about 5 degrees off for Seattle between the weather conditions. A lot of our load is related to heat, so we're a winter peaking utility. We have about 500,000 meters and about 1 million customers. And as I said, we're right at about a 2 gigawatt utility. So what do? I've been thinking about, when you said that, how I would want to answer. And what I'd say is that our team is responsible for this world where we have these physical assets that folks have been really comfortable with, that utilities have been installing, and then these technology assets that we've been pretty much okay with installing in the IT side of the world and the business side of the world. And now what we're doing is bringing these two together in the operational technology side of the world. And it's been a little bumpy, right? So our team right now is really working on learning architecture. And when we say architecture, this is really about the technology architecture side. So what's reference architecture? What's business architecture? And it's been a good conversation to have but has been challenging because you don't really learn that. I'm not sure that term existed when I graduated from college. At least not on the power system side. What do I see as the benefits of AGI? I find it to be a much more intimate way of connecting with researchers. When you're working in a utility, it's really easy to just work inside the utility. So by coming here, by having relationships, we're able to kind of bridge that gap. It broadens my outlook. It helps me see what's happening outside my organization, not just with researchers, but with other utilities. And many times when you go to a conference, you get really a light touch amount of information. At AGI, I feel like we get more details, more of that kind of meaty engineering conversation. And it allows us to make relationships with students also. A great way to kind of say, hey, we're here as a utility, think about working for us. So it's a great place to be. Thanks for inviting me and letting
Thank you, Isma. Very good. Thank you so much. Okay, Nicole, who just recently joined our board, look forward to hearing your thoughts.
Thanks, Peter. My name is Nicole Rutherford. I am the Chief Technology, Innovation, and Strategy Officer at Bonneville Power Administration. My colleague Mike was the keynote this morning, so he educated you all on Bonneville Power. So I'll save you. But like Peter said, I am relatively new to the advisory board. I joined them about 3 months ago. So I'm excited to be here. I would say that my priority and my hope for the relationship with AGI, Uzma touched on it, is really the access to the students and the research. A lot of these panelists, no disrespect, may not have 20 years left in the industry. I do have 20 years left in the industry. So I'm looking at the future, the access to students, the excitement, the research areas to help recruit, help retain, look at the workforce, which was touched on a couple times today, but that's my priority and area of focus.
Cool. John, we've heard from you before, but we'll give you another chance here.
Still recovering from that 20 years. I don't think it was pointed. But so anyway, I'm John Gibson. I'm the director of Avista's Innovation Lab. Avista is an investor-owned utility. It's dual fuel and vertically integrated. So it has both natural gas and electricity, and you can imagine that's an interesting dilemma. It also serves eastern Washington and northern Idaho, two distinct political environments from the regulatory climate between that, which is a real challenge for us. Today, our supply resources that supply Washington also supply Idaho, and so they still have to be least cost resources. But in addition to all that, at the lab, we really have three areas of focus. The first is what we call strategic, where we're trying to identify the products, or trying to create a hosting platform on our infrastructure for third-party products and services. The second is around what we call capital efficiency. As we obtain insight from all of you into the types of technologies we'll deploy on our system, they might also work not only at a strategic level in regards to strategic projects, but they might support the existing capital work that we're doing. And so we might embed those capabilities to essentially improve the efficiency of how we execute capital projects. And then the third is around an ecosystem. And if you were in here this morning, you heard a lot about intent. And that's a regional innovation engine that we're focused on developing at the Avista Innovation Lab. In regards to AGI, we are partnering with AGI on a variety of projects. Anamika mentioned a couple of those. One of them is around connected communities. And this was funded through the Department of Energy, and we're looking at this grid intelligence deployed to support aggregation of demand response resources on our system that are more locational based. Rather than just being a virtual power plant, we're trying to address the challenges of the delivery of that energy. What's unique about our system is that on the supply side, we are winter peaking. On the delivery side, we're summer peaking. In other words, because of these heat dome events, it's difficult to even deliver that energy. So this idea of locational based demand response or this or aggregation at that level on the circuit is important for us, and so that's why we're looking at that. But in addition to all that, just the opportunity to obtain insight from all of you in regards to where the technology is leading, what kind of capabilities are out there, and hopefully we can help partner in showing you some of the market drivers that we're trying to face and regulatory drivers we're trying to face, and how do we essentially leverage that technology. So I find that kind of partnership helpful.
Thank you very much. Eleanor, you're next.
Good afternoon. I'm Eleanor Uri, and I'm the manager of transmission strategy and planning at Puget Sound Energy. Very similar to Avista, we are an investor-owned dual fuel utility, so we provide electric and natural gas service to our customers. Our peak load is about 5,000 megawatts, and we have, I think we're up to roughly 1.2 million customers, electric meters on our system. So in my career, I've been very entrenched in the transmission world, and one of the things that we're seeing right now is a shift away from what I'll call traditional transmission planning, where we're focused on just system capacity and reliability, and we're starting to focus on transmission development for resource delivery, which is a new world, at least for PSE. So for context, again, our peak load is 5,000 megawatts. In order to meet our clean energy goals, we're looking to procure 15 gigawatts of clean resources, half of which will be located remote from our service territory. So it's a pretty big lift over the next 20 years to get to that point. And I think what AGI provides for us, I think that the big theme of today is that this is not a PSE problem, and it's not an electrical engineering problem. This is a utility problem. This is a regional problem. And we've talked about climate science and earth sciences and agriculture and how that all plays into the energy outlook for the system. And so just as a utility not being able to really pull all of those together as we try to just keep the lights on for our customers and keep our rates low, we really are dependent on institutes like AGI to help us with that broader picture and to pull all those different industries together for the benefit of the grid.
Thank you, Eleanor. Very good. And Larry, as I warned you, you get to go last.
Okay. Well, good afternoon. Larry Beckett, Senior Vice President for Advanced Energy Delivery at Portland General Electric. And so we're kind of much like a Seattle in the sense of about 1 million customers. And also our load is closer to what Puget Sound Energy, 4.5 gigawatts was our peak. And we're almost dual peaking now. So we were kind of summer, but this last winter came back with a race a little bit. It came right back up. So we were almost at 4,500 megawatts at the winter time as well. So we're seeing the fluctuations. We're seeing the growth take place. And I guess, I don't know, Nicole, if I should thank you or your boss, Mike, about the comments. I guess I'm the old guy here. So actually, in June, I did hit my 40th year in the industry. So, yeah, thank you. To the core, to Clark Public Utilities, to Bonneville, and then now to Portland General. So kind of seen all the colors of utilities and what goes on in the Northwest. And so love putting the pieces together. And just like here, love to learn and love to, that's why AGI is so important, is for us to come together and learn together. So as has been mentioned a few times around on the table already, growth, I'd put that out as one of the number one issues right now. We were kind of on a path with electrifying the industry, electric vehicles, heat pumps, et cetera. We were all kind of going, yeah, we went from what used to be a 1% growth rate or less to 2 to 3%. And then we had a CHIPS bill come about. And so, again, Intel, being in our backyard, has exploded. I'm sure the Microsoft, the world, everybody else is. We're domesticizing chips into the States. And again, there's a national security issue. I think, John, you touched on it. And then also on top of that became data analytics and what has happened with data centers. And so, and again, roughly half of the data centers today support Department of Defense. So again, national security is right up there on top of, you know, what's been going. But then you step back and you say, what's going to go with autonomous vehicles? What's going to happen with robotics? What's going to happen in analytics in our business? Machine learning, that's physics-based, that's going to start to roll out very, very quickly. How do we process? Where does that happen? And so machine learning and in these large learning models are going to change the face of what we do. And recently had the opportunity to work. The Secretary of the Department of Energy was asking, what do we as an industry? And so a number of us got together to think about and wrote a paper that's out there for DOE as to how do we meet these new large loads. And so it's a challenge. It's what all of us should be thinking about because they're asking to double some of the loads that we have. We've got roughly 3,500 gigawatts or 3,500 megawatts on a 4,500 megawatt system that's requested right now. So it is stunning when you sit back and you think about that. So that's the number one issue. And oh, by the way, it's got to be affordable for everybody. So who pays for all of it? You know, it was easy when it's distribution, substations, feeders. But when you get into the network, how does that, who pays for, how does that get done? And go back to the last century, and I think it was Mike talked about the aluminum industry and those types of loads, 100 megawatt plant dropping in, just like what a data center is. Except they're a concrete tip up. They can have themselves up and running in 18 months. We don't get time to build alongside of them. We want it as fast as possible. So when it takes you 4 to 5 years to get a transformer, we're struggling. The second issue that I would bring up was resiliency. We want to talk about that a little bit, but wildfire, it is a utility killer. So right now, it was talked about insurance, and for any one of us, that could be the death for that utility, given the lawsuits that are associated with it. And so you'll see legislation, a lot of activity that's trying to work around that. How do we find that solution? But it is a social issue. It is not just a utility issue. And so we've got to resolve that somehow very quickly. The resiliency on the other side, I mentioned earlier with weather and what's happening, the 50-year asset. What does it look like? What kind of ice loading? What kind of wind loading? What kind of fire prevention? What do we do to make sure, much like we've done for the last 135 years, what does that asset look like going forward? And the final one that I want to put on the table is, it was mentioned, the grid enhancing technologies. It's how do we get the most out of the system that we currently have? And so I was recently at a public meeting on a transmission line, and they're real popular. Lots of people like to attend, but they're usually not in favor of the transmission line being built. But I had an individual who came and was with a particular organization, and she pulled out an article and her book, and she said, "Oh, Larry, what do you do with these grid enhancing technologies?" And she's got a book and she's reading through all the stuff that has been created by our industry. She has nothing to do with our industry, but she's really interested because she wants to make sure we're getting the most out of the system that we have currently. And so all of us are going to be challenged with that. And we need to think very, very hard about whether it's advanced conductors, is it dynamic line ratings, are we doing the inertia-based review out there? Are we using smart wires type technologies? All of that's going to be very, very important. And I know, yes, I won't be around for 20 years. And unfortunately, the only line that's been tried to be built in the Northwest has been in the makings for 21 years and still has not been built. So we have to rely on the lines that we have currently. And that means a different planning profile. We got to think about the lines that we currently have and how do we convert them, reconductor them, and use the easements that we have already. So those are the hot ones that I have. And the last will be analytics across all of it. So you touch any of the things that we do, whether it's the asset itself, the operations, the planning, it's all coming down to analytics that we need to get really good at.
Thank you, Larry. So I was going to ask the panelists to get into a little more detail on specific R&D priorities. You touched on that, Larry, especially given what you've already heard, what the AGI is doing, what's going on at PNL, what's going on at WSU. So a little more specifics on what you see what the AGI priorities should be, or what you see as your industry's, your company's R&D priorities. And Greg, since I cut you off, I'll let you go first if you want to talk about your R&D priorities.
Greg from SEL, I'm assuming. SEL. Yeah, so I think some of them have been talked about to a degree at the meeting already. For example, in the discussion of inverter-based resources, SEL's history when we first started the company was around protective relaying, and inverter-based resources, they don't act like a synchronous machine. They don't operate on the same laws of physics, so to speak. There's a lot of firmware involved in IBRs, and so how do we protect and control electric power systems when there's a high degree of inverter-based resources? And one of the technologies that we've developed and we think is an interesting idea is around traveling wave, because traveling waves, that protection-based approach, it's based on the energy being delivered from the fault, not from the machine. So we can kind of switch things around and say, can we make things less dependent on the source, more using the information from the fault itself, and then we can just completely eliminate the problem, frankly. And that, I think, is a really interesting area. But there's a lot of research going on in this area. I know Saeed's been working on it. I listened, it was a great talk, Saeed. And so I think that's something of interest to us. Protection, of course, is also impacted by the fact that we have different kinds of power flows now. And so there's just a lot of things in protection research. Another one that, do you want me to go through all of them now, or do you want me to go through them one at a time and then kind of round table it? I'll keep going if you want. It's up to you.
Yeah, keep going. Thanks.
Keep going? Okay, cool. Another one is cybersecurity. And, this is a big one because it's very cross-cutting. I think one of the concerns I have, and probably others, is that a lot of the cybersecurity solutions, I feel like, are just adding complexity to an already complex issue. And I've talked at AGI in the past. Unfortunately, I couldn't be there in person today because of a commitment. But when I talked there last time, I mentioned this previously, that I would like to see more of an emphasis in our industry on simplicity, on simplifying things, on frankly getting rid of some software, getting rid of some equipment, if that makes sense. But like, cybersecurity is one of those things where complexity just doesn't help. And so cybersecurity is an important one in terms of a research area. And I'm interested in cybersecurity solutions that doesn't just look like more code, if I could say it that way. Another one of interest that's actually kind of related is this topic of virtualization. There's been a lot of work and there's a lot of solutions. I mean, SEL ships solutions around virtualization, and I think it's a great way to basically improve the operational cost of like utilities and the power system. It can help us get things done faster, and so that's something that I think is an interesting research area. But it has to be balanced by what I said previously, that some of the solutions that I see and that I think there can be more work done on is how do we take advantage of what virtualization can bring, but not making it so complicated. So that's another research area. I'll mention one more, which is the concept of digital substations. So, it's kind of interesting to me when we say digital substation, because substations are already very digital. But really what's analog is the path from the measurement device to the protection, control, automation systems. And that's where there's an opportunity to further digitize things, to drive the sensing equipment more out towards the primary equipment. And so, there's a lot of work in this area that probably many of you are familiar with. And I think that's another interesting solution. And I guess I would wrap up by saying, I've talked about technologies, but ultimately it gets back to what is the problem that we're solving. Larry mentioned some real challenges for utilities, and I think all of these are aspects of finding ways to provide solutions to those challenges, because ultimately it comes down to safety, reliability, economics, and the environment, all those different things, and how do we apply these technologies to solving those problems?
Great. Thank you, Greg. So some of you talked a little bit already about your priorities, but some of you did not get a chance. So anybody else want to add any more? Nicole?
Yeah, I guess what I would say, BPA, I would say, is a little bit more risk adverse, both federally statute wise and probably just because we have a more risk adverse just executive team, as you guys probably know. But our research tends to veer towards more advance in development. So right now, a lot of our focus is on upgrades to equipment. So precision timing, we're working really closely with PNNL right now. BPA has an aging infrastructure. That's not a challenge unique to BPA, but we celebrated, what was it, our 87th birthday last week. And technology advancement is both a friend and a foe at BPA because we need that advancement to look towards the future and to think about the evolving grid and load capacity and those concerns. But we also have an execution workforce that's working on equipment that could be 50, 60 years old. And so if our manufacturers aren't making the equipment anymore, where does that leave us if our supply chain can't support our equipment and ordering that material? So our focus is right now more executionable, if you can say that. So more tangible, as that's where we're focusing. We have 19 research areas. A lot of them are on the resiliency.
Thank you. Rich?
Yeah, just to add a little bit, we're of course looking at inverter-based resources. We're looking at virtual power plants. We're looking at, again, trying to leave no stone unturned. And I get that, and we totally support, the research aspect of AGI. But I do ask us all to be responsible, right, when we're talking about research. Because Larry, you mentioned, having customers show up, and I will tell you, we have customers that will show up based off of information they hear about technology advances and want to know why we're not doing it today. And, then you get into a discussion about novel technologies and the practicality. So I think that balance of the art of the possible and the art of the practical will continue to be important for us to all make sure that we're coalescing around, because there are regulatory and legislative hurdles that we're all trying to maneuver through. We're trying to build 42 miles of transmission right now. And this project's been in place now for about 4 years. And we have, everything from landowners, opposed to it because, they're saying, well, you can just put superconductors. There's 4 times the capacity out there. That's what we're hearing, right? And so getting into those kind of conversations with impassioned people, and I completely understand, but it does create a dilemma if we're all not in this together. And I say that from COU, IOU, legislators, everybody, including the public. So I think that's something that we're finding out day in and day out, the importance of informed stakeholders throughout the entire project.
Thank you. Anybody else? Lisa?
Thanks. So just kind of in response, Rich, I think change is the thing that really is stressful for our customers and for our employees and for us. Places where I see change happening, flexible load, really thinking about what that means. We are also participating in a different Connected Communities project. We're also starting demand response, which is kind of something that's a little new here in the Pacific Northwest. And it's how do we change the way that we think about the grid? How are we going to ask individuals to do things such that they benefit the grid? How will we build those incentives? And that's proving to be pretty challenging. It's a paradigm shift, again, change. On the regional transmission side, CETA, Seattle City Light's been greenhouse gas neutral since 2005, but it's still super impactful for us because CETA is a journey that we're traveling together, not each utility at a time. It's a statewide change. And I was really surprised recently someone told me that Seattle City Light has made a 2,000 megawatt request of BPA for transmission. I was like, what? So just to appreciate that that's a big change for us. And finally, I'm one of those people who thought that air gap was enough for cyber. And as a person who just flew through SeaTac and got to see the paper that said, sorry, we can't show you when your flight's leaving. Also, the Seattle Public Libraries have been having problems for about 4 or 5 months now. They've been working through various steps, but you can check out books for a while. They told folks not to return books. I think that, Ukraine 2015, 2016 happened that kind of gave us the heads up. But I'd also point out that cybersecurity challenges are every day all around us, and they're significant, and how you recover is really important. And I'm not sure that we've spent quite enough time on that topic. So I would love to just keep thinking about that, and really pragmatic, solution-based communications with utilities, how-tos, because when you have 64 utilities, perhaps they don't all have a multi-person cybersecurity team.
No.
Seems like a great opportunity.
I'm not sure if I got set up on that one. Well, so I what many of the panelists have talked about is, I would just say, yes, we have all of those challenges from cybersecurity, to fire and public service power shutoffs, how we're going to essentially mitigate that. You remember reliability used to be kind of the golden rule, and now we're compromising on reliability. Should we offer something in exchange, like resiliency? Is that an offering that we should think about? Then the other is around really customer programs. How do we engage with our customers and essentially give them the products and services that they're interested in, but do it in a way that's beneficial to the grid? And the moment you say that, it becomes locational. That it's not every customer has a constrained feeder that they're on, but some do. And it would benefit us if they could deploy certain sets of assets that would improve the utilization of that grid. But that's not universal, so we'll have to get to a point where we can start crafting these programs in a way that can be more targeted. The model that everyone builds on is this concept of energy efficiency, right, which was kind of a peanut butter approach to a problem, that over time, organically, you would see a reduction in load. Well, the problems that we're facing are really challenging. The other is, not to sound like a guy who sells natural gas for a living, but natural gas doesn't need to be an energy resource. It can be a demand resource. And it can help to bridge that time to improve the utilization of that electric infrastructure. You don't have to run gas all the time. You can just run it during those peak conditions. As a demand resource, I think it's viable. Because the reality is, that's what the supply is on the grid at that time, is from natural gas. And it's less efficient at the generator's resource rather than delivered at the meter. So anyway, that's another thing. That's a practical type of solution to a challenging problem, but the politics get in the way of that. There's no bridge to the future. It's kind of now or never. So I think there's a lot of opportunities.
Thank you, John. Unless there's other urgent thoughts, I do want to open up to it, but go ahead.
Well, two more things. One, you brought it to light, this notion of customer programs, John, and it's how customers perceive what they're experiencing. So we all know that to get to the renewable, there's additional cost associated with that. It will happen. However, they want to know, how can they participate? Don't make it complicated. I don't want to sit and play with my phone and have an app that I have to do a bunch of things with. They want to know that their devices are doing what's best. But what we have seen, making it something simple on their bill that shows, kind of right up at the top, you saved $5.38 this month by participating in demand response program, whatever it is, whatever you call it. They kind of go, oh, look, hey, I did save something. Or if on their electric bill, if they've got an electric vehicle, it appears that you charged X amount of hours and the cost associated with that, comparable gas price is X. You know, how do we change the energy wallet? But it has to become visible for customers to start to understand and think about it. If it's not there, it's out of sight, out of mind, and they'll continue to be thinking, oh, my prices are just going up. Why? And there's no value to me. So how we bring value to customers is really important as we go through this. The second one that I bring up is grid edge. We didn't really talk much about it at this point, but grid edge in the sense of meters. Meters will become the iPhone of the future. It will have apps on it. It will become that device that carries a lot of things, can do a lot for us. And so what are those apps you want to put on there? And that can be as simple as, being able to be the auto transfer switch as a meter, for switching between the utility and the backup generation, which might be their solar and battery in their house. It's a great demand response program, but it's also resiliency for a customer. And oh, by the way, you just saved them $10,000 on an auto transfer switch that they didn't have to pay for. So that's software enabled. And how do we do that? How do we start to push ourselves to get to that sort of linkage? But there's all kinds of apps out there that can, help us operate the system a lot better. That's just one example, but meters are going to become that of the future.
Thank you, Larry. I know these guys could probably go all day on different things that they want to talk about, but I do want to give the audience a chance to weigh in on their questions for this industry panel. You've got a great panel here from a lot of different perspectives, so I will open up the floor to anybody who has a question for the panel. Yeah, Hayden.
There's been a lot. Can you hear me? Yeah. There's been a lot made in the media about sort of the load growth, and you've cited the numbers, sort of akin to what we're seeing on the generation and connection side. How do you tell what of that may be real and what might be sort of double bookkeeping or shop around multiple utilities in terms of give a sense of that behind the scenes?
I'll hand it to you, Rich, here just a second. I'll throw out 2 cents worth is that I would say from a data center perspective, they'll take every megawatt they can get. Now, where it's located does matter. They do want to be at certain places, but they will take anything they can get right now. There is some, if you're talking to what I'll call the third-party leasers, that could be a QTS, a Flexential, a Stack, those type. They're leasing to Google and Amazon and others. Yes, some of those are duplicates out there. But if you were to give them the space, they'd fill it tomorrow.
Yeah, and for us at Grant, we talk about it a lot, speculation, right? Speculation in the queue. We have gone through some deliberate customer queue application process fee adjustments to ensure that we are weeding that out. And I'll tell you, we started with 3,000 megawatts, and after we made the adjustments, we now have 3,200 megawatts. So I think it goes back to what Larry said. They are attracted by land costs and power costs. And, for our large industrials today, I think the all-in rate's about 3.5 cents. It's pretty attractive. So we're trying to send them the market signals based on what we're anticipating the 5 and 10 year, rate trajectory to look like. And what we're finding out, at least with data centers, is we could probably charge a lot more and they still would stay in the queue.
So, you mind if I ask a question for the panel? So, in regards to that, where does Bonneville sit in this in regard to its supply and its tier 1 and tier 2 rate? How close is Bonneville essentially exceeding its tier 1 and the allocation? I just kind of interested because of, if you can offer energy at 3